LEETCODE question 743 network delay time, and this is a median LEETCODE question. So you're giving a network of n nodes and labeled from 1 to n. You're also giving times or list of travel times as dedicated edges. Time I equals to UVW, where U is the source node, V is the target node, and W is the time takes from our signal to travel from source to target. So U is the source, V is the target, and then W is the wait, basically the time it takes. For example, it gives you the times array. So it takes 1 wait to travel from 2 to 1, and travel 2 to 3 takes 1, and travel from 3 to 4 takes 1. So the times describe exactly what it is on the graph here. We will send a signal from a given node k. So it will give you so n equals 4, their total 4 node here, and it gives you a source node, which is 2. Return the time it takes for all the n nodes to receive the signal. So it needs to ask you if it's impossible for all the n nodes to receive a signal, return -1. So in this case, it takes all the nodes to receive the signal, then k equals 2 from node 2. It takes 1 to get to 1, right? And then takes 1 to get to 3, and it takes another 1 to get to 4. So the time total is 2 in this case, right? That's why the output is 2. And then there's another example here. It takes from node 1 to node 2 takes 1, and n equals 2, and k equals 1 from 1 to all the nodes 2, and then that's why the output here is 1, right? And then from node 1 to node 2 takes wait as 1, and n equals 2, and k equals 2 from node 2. So since node 2 is the destination, there's no outgoing thing, so then it will return -1 in this case, and there's some constraints here, and you can see, and this is a question asked by Google and Amazon a few times in the last 6 months, and this is basically shortest the distance question, and shortest the distance, and if you know, this is actually the question, a typical dijkstra shortest the distance algorithm. If you use that, you can solve this this problem quickly. Basically, you want to write out it's kind of, this algorithm is kind of similar to buffer search, because it just go through its neighbors and it's guaranteed to find out the shortest path. It's because in the algorithm it use a data structure called minimum heap. So we're gonna continue to pop from the minimum heap, and what I want to pop from the minimum heap is for example, like I want to do pop from the minimum heap, right? And I want to pop from minimum heap is the first value is the weight or the distance or whatever it, or the time or whatever you want to call it, and then the second value is the node, and at the beginning I'll set the weight to 0, right? And then the node is 2. Is because the beginning node is that you will start sending the signal from k node, basically 2 in this case. So this is the value that I want to add it to the minimum heap first, and then I'm gonna continue to pop, and I pop the value, and then I'm gonna do the same buffer search on this nodes 2's neighbor, and I'm gonna run the same thing and push the value into the minimum heap. As you are popping, the minimum, one of the characteristics is that minimum heap is guaranteed to find the minimum value. That's why you have to make sure that you put the weight as the first value and node as the second value, because you want to find the minimum weight. So that's super important. So when you pop, eventually that you will be able to get the least number of weight that you're looking for. And then I'm also going to use a visit set to make sure that I don't visit the same node again. And in the end, if we visit every single node, like all nodes, that means the signals are send it to all the signal, and then I can return the result that I'm looking for. If I'm not able to find the result, I will return -1 in this case. And yeah, let me show you how to do this in code. So basically, this is a typical graph problem. So you want to write the times this array into our adjacency list. That basically is something like collections or collections.default and list. And then you define the adjacency list first, and then for the instead the times value is UVW. So for UVW in times, so every single value in this times, I'm gonna append the V and W into U to the source node. So if you look at this source, destination, and weight, right? So UVW, and then after you write this, the adjacency list basically will look something like I'm just giving you like roughly example, like a 2 can get to node 1 with 1, right? And then 2 can also get to node 3 with 1 weight of 1. And then there's also another item, which is 3 in this output, and the 3 will be 4 and 1 in this case. So yeah, that's how the adjacency list will look like. Once we have that, I mentioned that I will use a visit set to make sure that I don't visit the same node again. And then result is I'll set it to, it asks you how long, what's the return the time. So I'm gonna define the result, basically the time as 0 at the beginning, and I'm gonna create a minimum heap. And for the minimum heap, and I'm gonna append the value as weight, I will append it as 0 at the beginning, and the k is basically the starting node. So the value is weight and the node, right? The sequence is really, really important. So then I'm gonna say while min heap exists, all right, I'm gonna start popping from the minimum heap, and the things I pop out is the weight and the node, right? Heap q dot heap pop. That's how you pop from the minimum heap. And when you pop, you have to include the name of the heap. And then you basically, at the beginning, this value is basically 0, 2, and the weight is 0, and the node is 2 in this case. After that, I'm gonna check that if node in visit. If the node is already visited, that I'm not gonna check its neighbor, so I'm just gonna say continue. Otherwise, I'm gonna say visit add this node to the visit set to show that I visit this node, and I'm going to visit this node. And then after that, I'm gonna update the result. The result is basically the k and the result. Right now is 0, right? And the weight and the result, whichever is the bigger one. So it's the max of the result and the weight that got popped out, right? Because the weight's gonna get updated. Right now the weight is 0, but then after I visited the neighbor, the weight's gonna get updated. So then that's why I have to update the result. And then I'll say for neighbor and the cost, I'll use cost for now. So basically for this neighbor and the cost here in the adjacency list node. So basically for example, the node is 2, right? So the neighbor will be 1 and the cost is 1 and neighbor is 3, cost is 1 here. I'm gonna go through this list. If neighbor not in visit, if the neighbor node, if like node 1 has not visit yet, what I'm gonna do is I'm gonna append the value, push the value into the minimum heap so that I can find the minimum value. And how do I do is heap q dot heap push, and then I'm gonna push into the minimum heap that I created, and then the value I'm gonna put is, so when for example, like if I wanna append the value to the minimum heap, it's actually not just, so there are two value. One is the weight, right? And then the second value is the node. And at this time, because it's the neighbor, so when I reach the neighbor, I also have to add, so I will actually be adding the weight and the cost. Basically another weight, but it's a different name that I give to make sure that I add all these value together, because it takes 1 to for 2 to get to 3, but when I visit 4, right, I need to add this one and also this one. That's why the weight value will actually be cost plus the result that I calculated earlier, and then the node will be just the neighbor node itself, right? And then after that, that's the main function of the buffer search. Basically, dijkstra shortest the distance, and I want to return the result if length of visit equals to n. If that means I visited every single node. If I'm not able to reach all the node, and I'm gonna return -1 as it indicated. Okay, let me know if you have any questions. If you like the video, please give a thumbs up and subscribe to my channel, and I'll see you soon with more LEETCODE questions. Bye bye.